Welcome back to the deep dive. So today we're looking at a piece of hardware that basically looks at the laws of physics and then just finds a way to cheat.
It really does. We're talking about the NTI ST FODP14 MPO. It's an 8K DisplayPort extender.
But it's more than that. It's like a bridge between this dream of, perfect ultra-high def video and the reality that signals just die over distance.
It is that classic fight, isn't it? Bandwidth versus distance. We're trying to push a full 8K signal that's 7680 by 420 pixels.
And not just across a room, up to 300 meters. That's almost 1,000 feet.
Yeah.
Which, for a standard copper cable, is just, it's impossible, right? I mean, after about 15 feet, a copper DisplayPort cable basically becomes an antenna for noise.
Precisely. The signal just degrades into nothing. Copper was never designed for that amount of data over that kind of distance.
So this NTI unit just gives up on copper.
For the long haul, yes. It switches to fiber optics, specifically a 12-strand MPO multimode fiber cable.
Okay, hold on. MPO. That's not a term you usually hear with video cables. That sounds more like data center tech.
It is. Think of it less like a single garden hose and more like a 12-lane highway for data. It's a multi-fiber connector.
Ah, okay.
And by using that MPO architecture, this thing opens up a massive bandwidth pipe. We're talking nearly 24 gigabits per second. It's not treating video like a signal anymore.
It's treating it like high-speed network traffic.
Exactly.
Which makes sense when you see the price. It's, what, around $1,600, $1,700? You're not buying this to hook up a game console in the living room.
No, this is for environments where good enough is a serious problem. The specs talk about sensitive applications, and that's really the key here.
Because it's light, not electricity.
Right. Fiber is totally immune to electromagnetic interference, EMI.
So you could have, say, a medical imaging suite. There's an MRI machine just blasting out a huge magnetic field. A normal copper cable running through that room would just get shredded.
It'd be unusable. You'd get artifacts, flickering, maybe a total signal dropout. And if a surgeon is looking at a live feed from a camera inside a patient,
they can't have signal noise that looks like, actual medical data.
They absolutely cannot. This device guarantees that what you see is what's being sent because that magnetic field literally can't touch the light in the fiber.
Okay, but there's always a trade-off. Physics demands a price. To get that 8K signal 300 meters, there have to be some limitations.
And there are. The specs say it supports 8K, but it's capped at 30 Hz with YUV 4.2.2 color sampling.
So it's compressing the color information a little. That's the 4.2.2 part.
It is, yeah. It's a slight compromise on the color data to fit everything down the pipe, and it limits the refresh rate.
So for something like digital signage in an airport or a medical scan where the image is mostly static, that's perfect.
Absolutely perfect. But you wouldn't use this specific mode for, say, high-speed gaming where you want 120 frames per second.
I'll get 8K anyway.
Right. But it's flexible. You drop the resolution to 4K and you get your 60 Hz back. Drop to 1080p and it can do up to 144 Hz. You just have to match the mode to the job.
Speaking of matching, I saw a note in the manual, a pretty strict one. It says you have to use NTI's own specific DisplayPort cables.
Ah, yes. The closed ecosystem.
You could call it a cash grab, but with this much bandwidth, I'm thinking it's more like a quality assurance tax.
I agree with that. I mean, these high bandwidth connections are incredibly finicky. Use one cheap, uncertified cable at either end, and the whole system might just fail the handshake.
And default down to 4K to stay stable.
Exactly. So by mandating their own cables, NTI is just guaranteeing the pipe is clean and wide enough from end to end.
So you're not crippling a $1,700 extender with a $5 cable.
You're paying for the guarantee that the pixel leaving the transmitter is the exact same pixel arriving at the receiver 3 football fields away.
It removes distance from the equation for people designing these complex systems.
It does, and that really brings up a bigger question, I think. As we start pushing past 8K towards 16K displays and beyond, are we at the point where copper is just obsolete for high-end video?
I think we might be. Thanks for listening to this deep dive. Go check out the show notes if you want to see the specs yourself. We'll catch you next time.